Hello, welcome to the Bodhana, the platform which gives the complete content related to the engineering courses. If you are new to here, I am Dr. Ramesh. As part of this series, in this video, I am going to discuss about the syllabus related to the applied physics subject. Coming to the applied physics, this is one subject related to your first BTech, either in first sem or the second sem. It completely depends upon the branch. For example, in a particular college, if you belongs to CSC, it may come in the either first sem or second sem. The same way, if you for the ECE students or the triple student or the civil student, it may come into the other semester. Coming to the subject point of view, there is one of the important subject as part of your curriculum, as it has 4 credits as per credit system point of view. The BTech, the completion of the course is completely decided by the promotion first year to the second year to the third year, and the completion of the course is decided by the credit based system. This subject has 4 credits as per JNTU curriculum. Coming to the syllabus point of view, the total portion of the syllabus is divided into the 5 units. The first unit is related to the quantum physics, introduction to the quantum mechanics and solids. Coming to the quantum mechanics point of view, as you know that Newton laws are related to the classical mechanics. We have well known about the intermediate portion point of view. And coming to the classical physics, it only explain the macroscopic bodies. Macroscopic is nothing but the object which can able to see by our eyes. That is, the bigger object's behavior successfully explains by the classical physics, but it is unable to explain the microscopic particle behavior. Because of this, there is a new science related to the quantum physics which successfully deals about the microscopic particles. And coming to the solids point of view, how the solids are classified into the conductor, semiconductor, insulator, how the electrons are behave inside the solid material is explained by using different theories. That part is there in the solid part. It includes the Bloch theorem, Kronig-Penney model, free electron theory, Fermi-Dirac distribution, and classification of materials based on their bands. And coming to the second unit, that is semiconductors and devices. This is one of the well-known topic to you. As intermediate portion, you have the semiconductor, that 60 to 70% of the portion is similar to your intermediate course. In semiconductor, it starts with the how the semiconductors behave with respect to the temperature and with respect to the dopant, and how the materials are classified into the based on their doping point of view, intrinsic and extrinsic semiconductor, and their Fermi level behavior with respect to the doping concentration and the temperature formation point of view, N-type and P-type semiconductors, and the band energy formation, P-injection diode, and then the importance of P-injection diode, Zener diode is also the part of the semiconductors. Coming to the devices point of view, by using the P-injection diode, we can construct the LEDs, laser diode, semiconductor laser, avalanche photodiode, pin photodiode, etc. All these discussed in the second chapter. That name is semiconductors and devices. Some cases we can call it as physics of semiconductors and devices. Coming to the third unit, it is a bit lengthy as compared to the other units because it covers the 3 different kind of materials. One is dielectrics, second one is the magnetic materials, and third one is the energy material. All comes under the third unit. In the part of dielectric, we used to discuss about the different definitions related to the dielectrics and the polarization mechanics, electronic polarization, ionic polarization, orientational polarization, and space charge polarization. In addition to this, application point of view, LCD, liquid crystal display, and the other part is like a crystal oscillators. Coming to the magnetic material, how the materials are classified into the dia, para, ferro, how the materials are behave differently based on the different condition. That part is there in case of magnetic materials. And coming to the hysteresis point of view, how the ferromagnetic materials possess the hysteresis nature, and how the materials hysteresis nature is explained by using the domain theory that is there in the magnetic material. In addition to this, the magnetic bubble memory is also the part of the magnetic material chapter. And magnetic sensors is one of the application related to the magnetic materials. Coming to the energy material, that means the material which can be used to store or generation of energy, that can be part of energy materials. In this, first we will discuss about the conductivity in case of solid and ionic electrolytes, conductivity related to this, and then we discuss about the lithium ion rechargeable batteries and energy storage devices, supercapacitors. This part is there in the energy materials. Coming to the fourth unit, that is nanotechnology. Coming to the nanotechnology, as we know that nano means like a size related 10 power minus 9. But obviously, why this particular length is so special as compared to the ordinary material? Then obviously we should understand what kind of properties are changes with respect to the size point of view. If it is nano point of view, how the material is different as compared to the bulk part, that part we need to discuss. In addition, the materials production, how we can synthesize that kind of materials with dimensions 10 power minus 9, that part we need to cover in this particular thing. So the synthesis methods again classified into the different ways, like a bottom up and top to down approach. Chemical methods are generally called as bottom up methods, and physical methods are called as top to down approach. Top to down means the initially the particle is bigger and it crushed into the smaller, that is under the top to down approach. When you come into the bottom up approach, initially it's a molecular level and it comes to the particle level. And in addition, you have a doubt whether you prepared the material with the size like a 10 power minus 9 or not, how you can analyze which material it is. So this part will cover into the characterization method, that is structural characterization, and the morphological characterization is one of the most important parameter to check whether the materials are in the proper structure, or whether the material have the what kind of structure it is, whether it is shape like a 2-dimensional shape or 3-dimensional shape or the 1-dimensional, and what is the size, exact size that can be discussed by using the XRD, that is X-ray diffraction, SEM, a scanning electron microscopy, and TEM, transmission electron microscopy. These are the characterization tools we need to discuss as part of fourth unit. Then finally, in case of fourth unit, we just discussed about the properties, how the properties are changes with respect to the size. Second one, how we can fabricate the materials. The third one, how we can characterize the materials. This is about the fourth unit. And coming to the fifth unit, here also two topics are covered in the fifth unit. One is the optical fibers and the lasers. Coming to the laser point of view, abbreviation light amplification by stimulated emission and radiation is the full form of the laser. Then obviously when you compare with the ordinary light, it has different characteristics. That is one of the specialty to discuss about the laser as the additional chapter in BTech course. Coming to the ordinary light and the laser point of view, laser can travel more distance with high intensity. The power of the laser is very high, that can be used for the different industrial application, for cutting, drilling, welding, even laser guns for military. That's what obviously laser grabs the attention of the physicists to discuss with respect to the ordinary light. Then obviously when you compare with the ordinary light, the principle of the laser is completely different. Here stimulated emission is the one of the basic origin to produce the laser light, in addition to the population inversion. Then obviously we need to discuss about the basic concept related to the production of the laser. In addition to this, we need to discuss about the what are the different types of lasers, because lasers are produced by using the active material. That material might be solid, liquid or gas. So because of this, here we are discussing about the semiconductor laser, ruby laser, helium neon laser, and CO2 laser, and Nd:YAG laser. These are the different classifications related to the lasers. Coming to the optical fibers, generally for transmission of the signal from one place to another place by using the copper communication cables is the well known. But the problem with the copper communication cables is to send the signal through the copper communication cables can give more losses. That is one of the hidden drawback related to the communication. So that's what we are using the optical fiber communication technology to prepare the communication devices from one place to the another place. Here, in case of optical fiber communication technology point of view, total internal reflection is one of the basic principles involved in sending the signals from one side to the another side. Then obviously each and every cable can't provide the optical fiber communication point of view. We need to follow certain rules. That is, the preparation condition of the optical fiber must be to satisfy the total internal reflection. That is, the ray should travel from the denser medium to the rarer medium. Because of this, the construction of the optical fiber is one of the most important essential topic to discuss in the 5th unit. In addition to this, how signals can transmit from one end to the another end, what are the different types of optical fibers are there, and if any losses are present, what are the basic reasons to present the losses in sending the signal from one end to the another end, and that is called as attenuation of optical fibers. Communication block diagram, how the input to the output, how the optical fibers are performing, that is called as communication block diagram. And finally, we are discussing about the applications of the optical fibers. In part of 5th unit, 2 topics we need to discuss. The first one, lasers, and the second one, optical fibers. And coming to the total 5 units point of view, one is the quantum mechanics, the introduction to the quantum physics and the solids. Second one, semiconductors and devices. Third one, dielectric materials, magnetic materials and energy materials. Fourth one, nanotechnology and its important and the characterization. Fifth one, lasers and optical fiber. This portion gives the little bit knowledge related to the technological aspect point of view, so in different scenario. This is about the complete portion related to the applied physics. Thank you.